Hello, hey, welcome back. This lecture, we want to look at experimental variogram. So, experimental variogram, the term suggests that it's coming from an experiment. So, we've got a function, the formula that we can use to compute experimental data sets, then fit a variogram from the data sets. The formula is given by 1 over 2n bracket h. So n is a function of h. And then you sum that with respect to the difference. You sum that with respect to the difference of the location, which is your vector h. This is the difference of the measurements between those 2 points, which is ZUI minus ZUJ, and then you square everything. I think this will be clear with on the next slide where we look at an example. So what is NH? NH is the number of pairs of location separated by the vector H. And then if the points are irregularly spaced, the condition of summation is weakened, or the condition of the vector is weakened if only the points are irregularly spaced. But life becomes easy when these points are regular in terms of spacing. But in real life, these points are irregularly spaced. So this can be done to get an accurate value. This can be done by estimating, making some adjustment to the formula. Then the adjustment that you can make the adjustment on your vector and say ui minus uj minus the vector and allow a difference of sigma. This should be less than or equal to sigma. And then the angle, ui minus uj, this one should be less than or equal to delta. Right, so those are the adjustments that you can make. And then on next slide, I want us to look at an example. Right, so suppose you have got all the data points along a same line and they are equally spaced, and let's say this, you have got in our example we have got 10. In our example we have got 10 points, so this is 1, 2 up to 10, and then these are the measurements at each one of those points. And then let's say these points represent boreholes, and these 10 boreholes are in a same line as shown in that example. Then number one, note that this type of data set is in a regular form, so it makes life easy for us to compute variogram. So number one, you look at the difference between these locations. So this one is at 2 meters, and then this one is at 1 meter. This one is at 2, and then this one is at 1. So the difference between this one and this one, the first 2 is 1. The difference between this one and this one, the next 2 is 1. So you have got your vector there for consideration to be h1. So if you consider the vector of h1 along the x-axis, because you can see all those points are lying horizontally. So along the x-axis, the direction is very important when they are computing the variogram. So this will be equal to 1 over 18. Remember, what is the NH? NH is the number of pairs of locations separated by vector H. So how many pairs do you have? that are separated by vector h. You have got 1, 2, this is a pair, this is a pair 3, this is a pair 4, this is a pair 5, this is another pair 6, 7, 8, and then 9. So you have got 9 pairs. So 2 times 9, that's where this 18 is coming from. So you have got 9 pairs that are separated by vector 1, and then times 2, you get your 18. And then you need to compute the ZUI minus ZUJ, which are differences between two locations, their measurements. So the first two, you have got the measurement 41.2. So this is the 41.2 minus 42.2, and then you need to square that as per our formula. Plus, this plus is coming from the summation sign there. You see that summation sign? It's the one that is giving us this addition. So plus the next pair is 40.2 minus 37. Then the next pair is 37 minus 42. Then the next pair is 39.7 minus 39.2. And you continue all these pairs up to 41.1 minus 40.3. And then you square these differences, you square them, satisfy yourself that you get the following answer: 0.4917. And then if the difference, if we consider the difference of 2, so if the difference between 1 and this location 3 is 2, so you can see the difference there is 2, and then this will give you how many vectors? So this one will be 1, 2, so this is 1, and then the next, this one and this one, this one and this one will be 2, and then this one and this one will be 3, then this one and this one will be 4, this one and this one will be 5, and then this one and this one, all those with difference 2. You'll get how many? You'll get 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 2, this will give you 16. So this is 16. All those locations that have got difference of 2 meters. Let's say 2 kilometers for it to make sense, logical sense. And then this would then be computed as the differences would be 41.2 minus the next one with a difference of 2 kilometers, which is 39.7. The next will be 40.2 minus the next one with a difference of 2, which is 39.2. The next one is 39.7 minus the next with the difference of 2, which is 40.1. You continue this up to the last one. The last one in our example will be 40.0 minus the next one with the difference of 2, which is 40.3. And satisfy yourself that the variogram along the x-axis of difference 2 kilometers will be 0.756. Right. So as your homework, I would like you to look at this question. So you have got different points, unlike in the question that we saw on this example. This one has got a variogram along the x-axis and the variogram along the y-axis. So the first question, first part A, says calculate the experimental variogram values corresponding to the direction of 25 kilometers along the x-axis. And then part B says calculate the variogram corresponding to the distance of 25 kilometers along the the y-axis. So just a hint, as you can see, this one and this one, they've got a difference of 25, but this one and this one, they've got a difference of 50, so you don't include this one. We call this a computing variogram with missing data. You only consider the horizontal ones. For x, you only consider the ones with the difference of 25 horizontally, and then same thing for the y-axis, you only consider this one with a difference of 25, this one with a difference of 25, this one with a difference of 25, this one difference of 25, this one, and this one, and this one, and this one. Not this one, because there is a missing value and the difference is more than 25 then. Right, so finally, how then do you make decisions on data sets? In a real world, it is very critical to know how you select your vector. In selecting vector, normally we use trial and error or observation. Number two, for you to make good estimates or for you to come up with a reasonable variogram, you need to at least consider 30 pairs of different locations or more for you to have sufficient data sets. Number three, you need to select 2 to 8 fewer directions, otherwise your model will become too complex. Then lastly, to calculate the experimental variogram, you require several iterative steps, changing things, changing direction, checking the direction of tolerance and the leg distance. You can only get perfect in this type of modeling with practice. So hopefully you'll get to know how these concepts are applied in a real life. It's not the course, it's not the scope of this course though, but I'm open to discussing how we apply this if need be. Thank you.